So attendance enabled, guys. So mark the attendance, guys. Was there a class till now? Till 11?
Yes, sir.
Yes, sir.
Yeah, that is why people are getting late. It's fine. Yeah, whomsoever is joining, just mark your attendance. I still have 69 attendances. I just hope those of you who've just joined now, please mark it. And let's get these things out of the way. Okay, I think we have enough attendances for now. Let's hope that all those who are left will mark it. Um, do we have any volunteers? Yeah, Tia, you can mark the attendance. Do we have any volunteers for today? Okay. Do we have any volunteers for today? Let me also make it clear who have not shepherded before. I will prefer them first, and then if I don't have anyone, then I'll pick up other guys. Anyone who has not volunteered before, uh, has not shepherded before, but would like to be a shepherd today. Aman, okay. Aman is one. Anyone else? Sita, have you done it before? Okay, so Sita is another one. Mohit, you have done. Anurag, have you done? Okay, sorry, Anurag was for something else. It was for marking attendance. Um, Prabhav, Prabhav is one more. Prabhav, Sita, Parmeet, have you done it before?
No, sir.
Okay, so Parmeet, Aman, Parmeet, Sita, Prabhav. Okay, I'll pick one randomly to just keep the tradition alive. Uh, hmm, IT and CS1. Okay. Okay, I will put one. Uh, Prerak. Prerak, are you there? Okay, Prerak, you've been a shepherd, right?
No, sir, I haven't been a shepherd before.
Okay, then you are a shepherd.
Okay.
Okay, okay. So we have Prerak, Prabhav, uh, Sita, Parmeet, and Aman. These are the shepherds for today. Okay, and let me share the screen. Okay. So what questions have you already discussed? I think we have not discussed the diagram, right?
So we have discussed the diagram. We have to start from what are inputs here,
Okay,
whatever.
okay. So yeah, shepherds, you can start.
No, sir. Sir, study you were discussing about difference between procedure and algorithms.
Okay, so yeah, sure. So if anyone has any queries about that, please start with that, and we'll proceed from there.
You told sir that we will continue discussion. You will sir saying something about that.
Okay. So mm, yeah, you'll have to remind me. My mind is not really in the best form right now. So what is it that I was talking about?
So why the difference between procedure and algorithm? You were just giving the
Okay,
gist.
okay. Yeah. So basically, um, algorithms are in some ways just a more structured way of what we would have written, let us say, as a paragraph. Okay, so if I ask you to write an essay on how to solve a quadratic equation, you would probably keep on writing it in a paragraph. Okay, you'll start with some sentence, with then followed by another sentence, then followed by another sentence in a paragraph. Algorithm is in some ways uh, a more formal approach to writing this. It's just that you write every step usually on a different line. There is a sequence. Okay, so you say basically step 1 is followed by step 2 is followed by step 3, so on and so forth. So essentially, we there is actually very little that you can, I mean, there are very little constraints that you have when it comes to algorithm. So essentially anything that is written in a sequential fashion is in some ways an algorithm. Okay, that is doing something as an algorithm. Algorithms can be extremely vague versus they can be extremely precise. Okay, so one example that I can give you is, let us say, I ask you to write the algorithm for launching a rocket. Okay, um, so a typical PSLV rocket that we have right in India, it's a 4-stage rocket. So there are four stages, four parts of that rocket. So someone might actually simply write the algorithm as build stage 1, build stage 2, build stage 3, build stage 4, assemble them, put fuel, put on the launch pad and launch, right? um, so basically this is like, I mean, yes, if even this is an algorithm, but but then you understand that this algorithm is probably not too helpful, right? Maybe for the people who already know how to build each stage, okay, for them maybe this algorithm is useful. Okay, so they understand that this is how the stuff works. But for a typical person, this algorithm is probably worthless. Okay, you don't really know what exactly happened. So this is the problem with algorithms. Okay, algorithms can be extremely vague, they can be extremely precise. It's up to the person who's writing the algorithm. What level of detail would you like to go to. Now when we say procedure is a term that is associated with pseudocode. Okay, so pseudocode is basically one step before writing the code. Okay, now this is why pseudocode is usually associated with the programming language that you are going to use. Okay, so for instance, if you are going to write your code in Python, your pseudocode will probably look much similar to how Python code looks like. If you are going to write your code in C, your pseudocode will be far more similar to the C language. The idea of writing pseudocode is that it is just before writing the code, so you don't have to follow all the formal all the formalism that is required to write code. But you can, the more formal you are, the better it is. So procedures are basically a way to organize your pseudocode. Okay, so I say that in pseudocode there is a specific task. It is a coherent task. Coherent as in, I can actually say that, out of the 20 steps that I have in my algorithm, these 5 steps are dedicated to doing something specific. Okay, so for example, if I am solving a quadratic equation, there is one step where I calculate b square minus 4ac, and this has a name. It is called determinant. So discriminant, sorry. So you basically say, one of the way, I can actually say uh, calculating discriminant is probably a kind of uh, independent thing. Okay, so let us assume that this discriminant had some other function as well. Okay, it could be used not only for quadratic equations, but for, let us say, something else as well. So then you basically write that discriminant procedure separately. You say this is a coherent task on its own. Now this task can be a subtask for a larger task. Okay, so for example, if I want to solve quadratic equations, one of the sub task here is to find the discriminant. So I simply use that procedure that I already have. So essentially, if we go back to the basic question, what is the difference between algorithm and procedure. So algorithm is a very vague thing, right? I mean, there are no constraints on what an algorithm is. Procedures are something that you will find in pseudocode. Okay, pseudocode is already much more closer to your programming language, and procedures are just a way to logically structure your pseudocode. Okay, you basically collect set of statements, set of instructions together, which make sense. Okay, I mean, so for instance, I would usually not create a procedure that calculates b square separately and 4ac separately, right? I mean, it doesn't mean 4ac. What exactly does 4ac mean in real world? 4ac has no significance, but b square minus 4ac has a significance. There is a specific term for it. You know, we can say that I have written a procedure uh, to calculate d. So this is the idea, right? I mean, and as I said, there are no hard rules for it, right? What could be a procedure and what could not be a procedure. It's more about you know uh, structuring your thought process. You know, it's more about collecting your ideas, and then at the time of coding, the best use of procedures is that if there is a part of logic that is being used repeatedly, then you create a procedure for it, and you simply say, okay, now I'm going to call this procedure. I'm just going to mention this procedure here, and then people understand what it means. Okay, I don't have to repeat the same thing everywhere. So is it clear now, guys? Like, what is the difference between algorithms and procedure? Is there any no? Are there any more queries in this direction? Okay, so I assume, yeah, go ahead. Okay, so I assume everything's fine. Yeah, so Vanshdeep, this is right. So procedures are similar to functions. I have not actually introduced students to the concept of a function as of now, but yes, for now you can assume that they are similar to mathematical functions. Okay, so you guys remember that in mathematics you would write something like f of x comma y, right? So what does it mean? So basically it is a function, right? If I give you two values for x and y, let us say x equal to 1 and y equal to 3, this f of x comma y is going to give me a value. It might basically say f of 1 comma 3 is 9, or f of 2 comma 6 is 18, something like this, right? So what exactly is that f? I don't care, right? I mean that f could be anything, but basically my relationship with f is that I will give it two inputs, 0 and 1, 3 or 5, stuff like that, and it is going to return an output for me. So in certain fashions you can say that procedures are a kind of abstraction. You basically say this is a task. So for example, calculate discriminant. So I don't care how exactly is it being calculated. You know, whether the procedure has whether the procedure calculates b square first, or whether it calculates 4ac first. I don't care, right? At the end of the day, I just need b square minus 4ac. So this is the overall idea, that procedures are just informal ways to organize your code, which is more closer to human beings, right? So in theory, the computers don't care. Okay, you can simply keep on writing the same statements again and again. Computers don't care. But for us, for human beings to understand it logically, that how am I actually solving a problem, we can use things like procedures. Okay, any more queries? Or else we'll start with today's session. Okay, guys. So over to you, Shepherds. You can start with the next questions.
Okay, sir. Then I'll start by explaining this image. So basically, what happens here is that, as you are seeing, that this is the image of how to solve a quadratic equation. Okay, and we are given a, b, c, x1, x2, various these variables and constants. So what first I'll explain what happens in math, and then I'll draw the analogy. What is the difference between what happens in mathematical and what happens when you're doing a programming here? So, for example, you take an quadratic equation like ax square plus bx plus c. Okay, so here we know that the ABC are constants here in the mathematical equation. But what differs here in programming is that when you take this, then the user has to give the input for the ABC. So ABC can be given any value by the user. So here then the ABC values are not constant actually, it becomes a variable here because the user has been giving the input. Okay, then moving on, we then have to quadratic equation solver algorithm. Here, what we do is that we give the algorithm or maybe the formula for which how we are calculating here. Like for example, for discriminant, there is the formula b square minus 4c, right? So we use that, and then we use Seetha Vaishnavi formula to calculate the value of x1 and x2, which are all variables because they are also depending on the values of ABC, which are variables. So we put a condition, and if d is greater than equal to 0, that means the roots are still unequal, and then we calculate it like that. And if d is less than 0, then they are not real. So basically, the inputs which we are giving are A, B, C, and the outputs which we are getting are D, X1, and X2. Any queries? Hello, am I audible?
Yes, you're audible.
Any
So
support want to take it
if
from
you have
here?
any queries, then yeah, you can unmute and ask, guys. Okay.
Yeah, right. We all know that we have to use the if-else statement because we all know that first there are real roots and non-real roots. So if d is greater than 0, uh, then we have to like you have to use the if statement here, right? That if d is equal to 0, then the both of the roots are equal, and we use minus b by 2 into a. Otherwise, we use for the formula for d is greater than 0, or otherwise we use for d is less than 0. Any queries?
Why is it necessary to firstly set up a certain algorithm and then go ahead with the pseudocode?
Pardon?
Why is it necessary to first write down all the algorithms and then proceed with the pseudocode?
Right.
The
Can I answer this?
algorithm helps us
Can I answer?
decide. Yes. Okay, you want.
Basically, algorithm provide us the formal method for solving a problem, and by formal method, it becomes easy to write pseudocode.
Pseudocode is a formal method.
No, I'm saying that with the use of algorithm, we represent a procedure formally, and with the help of algorithm, we can easily write pseudocode.
Okay. You
Here
mean
we
there would
can
be no
say, yes,
errors?
we can say the algorithm is like a mental note or a rough note which we can further use to create the pseudocode for the same. Algorithm is like you first decide what we have to do and what will be the output for the following cases. For example, we have the quadratic equation solver. Here, first we decide if the d is less than 0, greater than 0, or equals to 0. If it is equal to 0, then it has two roots. It is a one equation. It is if it is less than 0 or more than 0, these are the other two equations. This is a part of the algorithm. Then comes the pseudocode. If it is equal to 0, then it has to run the following commands. If it is less or equal more than 0, then it has a different set of programs. It is all a part of the pseudocode. So it is necessary to create a algorithm first before we write the pseudocode or the main code. Hope this solves your answer.
So just one addition. So it is not necessary to write these, right? I mean, the only thing that the computer understands is code. This is basically a kind of preparation to writing your code. Okay. So as you actually become far more experienced programmers, you will probably start writing code straight away. But in the beginning, if you are new to programming, it is a good idea to first write an algorithm, then try to write a pseudocode, and then try to write code for it. Okay, this is more of a learning thing. It is not necessary. Your computer will not ask you if you have a written algorithm or a written pseudocode or not, right? I mean, your computer only asks you to write code. This is more of a this is more of a preparation to programming. Okay, go ahead.
So we can say for effective code, we should use an algorithm so that we can see all the sides and see what we are covering for the code.
Yeah, I got it.
Any more queries on this part, or we will move to the next question? So okay, so let's move to the next question, guys. I think we have discussed this box, is it? So is this box clear to everyone? Does anyone have any questions related to what this box is, what it means? Is anyone having any confusions? Okay, so I'm assuming this box is clear to everyone. Okay, and you have to stop us, right? So if you fall behind even after so much efforts, the onus is on you to learn. Okay, this is the best the shepherds can do for you. If you still have doubts, you have to become shameless. Okay, and simply keep on asking. That's it. We will only ask maybe twice and not more than that. So I assume that this box is clear to everyone. So let's move down. So can anyone actually pick up this question? So what exactly is this picture and what does it mean?
So this picture actually gives the idea of that we made a function discriminant which actually checks which actually gives us the value of the discriminant, which is b square minus 4ac as always, and after that we can get the value of d from the function and check whether the d will be greater than 0 or less than 0, and we can provide the answer for the same. If the d is smaller than 0, then all we need to do is to just say that no real roots exist, and otherwise we need to solve the equation minus b plus root d by 2a and give both the roots of.
So yeah, the idea is like let's focus more on those red circles.
So the box represents a pseudocode. Here we take the inputs A, B, and C from the user, but since it is a pseudocode, we do not need to define it as an int or double or a string. Then we decide that D is the discriminant calculator, which we have not yet shown. We just know that D is the another application which is not part of the quadratic equation solver for now, and the x1 and the x2s are the root for the quadratic equation. We use A, B, C to calculate the value of D, and the value of D helps us calculating the value of x1 and x2. It is as it completes the function of a quadratic equation solver, and the return output prints out the values of x1 and x2, giving the roots for the equation.
So basically, it means that A, B, C are given input by the user. So and D, X1, X2 are which we are calculating. They are the output that we have received by calculating the algorithm. Here the red circles I'm explaining. Then the red circle here 0 is actually a constant here, which we are not inputting the value. It is already given. Then 2 here, which we used in the algorithm here for, is also a constant, and likewise all the numbers here are constants.
So does anyone have any doubts about why A, B, and C are variables? Because in the world of mathematics they are constants, but here they are variables. So does anyone have any doubt about why it is so?
A, B, and C. So A, B, and C can be anything if there are variables. Since the program can decide if there are new integers, then it will carry on with the code. Otherwise, it will output an error saying that these should be numbers instead of anything else which it shouldn't be.
So ABC are just placeholders, right?
Yes, ABC are placeholders. They are basically going to hold the values of A, B, and C, right? But they are variables here because so it's like this. Uh, Let me tell you why I actually created this whole slide. The problem that some of you might face, especially those people who are doing programming for the first time, is because you have to actually change your mind from mathematics to programming. Okay, and this will take some conditioning. It will take some amount of time for you to understand that how do you make this switch from mathematics to computer science. So essentially the idea is something like this: when you solved a quadratic equation on paper, you never solved it actually for A, B, and C, right? You always had explicit values at the point of A, B, and C, right? So there will be 1, 2, 3, 4, something like this. And but you learned the process, okay, using A, B, and C. That it was taught to you that just in your head you replaced 1 with A, and let's say 3 with B, and 5 with C. You did this within your head, okay? So you knew that this is A, this is B, this is C. But in computer science that is not the case, okay? You will have to explicitly make the computer understand everything, okay? So if you are trying to solve a quadratic equation, these so-called constants are not no longer really constants, okay? They are basically how you define the quadratic equation for a program to solve it. So this is the switch that I'm talking about. I'm just hoping that it is clear to everyone. But if it is not clear, please ask, okay? If you are getting confused as to how did we make this switch, how is it that in a program we have x is not a variable but a, b, and c are. So if you have this question, this query in your mind, this is the point to discuss, okay? If you don't have, if you all have already understood this, then of course my job is much more easier. Then it means that I was probably assuming far too my approach was probably far too conservative. You guys have already picked up on how to how to formulate the inputs to a program. Yeah, sure, Raman, no problems. So if this part is clear to you, just realize that a big hurdle has already been crossed. This is for those guys who are doing programming for the first time, by the way. Okay, those who have already done programming, for them this is all regulation stuff. But for those people who are doing programming for the first time, if you have been able to understand these two pictures, okay, then you can say that you are basically now you have crossed a major hurdle. This is what I'm trying to say. So out of all those people, if you have any queries, please ask now. mm, of d you have to calculate the value of d, right, Vanship? How will you solve the quadratic equation otherwise? um So yeah, Ria, constants are something that are yes, for now just assume it is the same, that there is a way in which the constants get stored in the memory directly. uh, in writing algo and
Uh,
sequence. Yeah, go ahead.
Sir, what I was trying to say that in this pseudocode, it is not written that D is equals to B square minus 2AC, sir. So it will produce an error, I think.
uh Wait, no, it is saying, right, this D equal to, so I am calling a procedure here, this point. Okay, I'm not sure whether,
D, sir, is say you sir, D is as an external application which is used during the quadratic equation solver, where the quadratic equation solver contacts another application called the discriminant calculator, which takes the same input A, B, and C and calculates the value of B square minus 4AC and gives the output back to the D. So it is not required every time to type B square minus 4AC.
The D is actually predefined. We only have to use it.
D is not predefined. Discriminant calculator procedure is predefined. Okay, so what
So
happens is,
D we have to calculate like D is equals to B square for
yes,
minus 4AC. Then if D is equals to 0, else if D
yes,
greater than 0,
yeah.
otherwise it will produce an error.
So it's like this, right? So basically, the logic that your program contains is different from the data over which your program executes. Okay, you write the logic once, the data which is used to which is used at the time of execution can be different. Okay, so for this is why I say that when I write this program, the idea is that I am going to write the program for solving quadratic equations only once, and then any quadratic equation, all I need is the values of A, B, and C can be solved by this particular program. So the D part, okay, so discriminant calculator, I have basically written another procedure. Okay, and all this procedure requires are the values of A, B, and C. It will internally calculate B square minus 4AC and return the value. Is it getting clear?
Yes, sir.
Okay,
Yes,
sir.
sir.
Okay.
Yeah, just a minute. Devjyoti, x1 and x2 are also variables. So a good term for variables is, someone actually pointed this out, is a placeholder. Placeholder means that it is a place where some value can be stored. Okay, this is probably the best way to think about a variable, and over a period of time these values can be changed by you as well. So if you assign something to a variable at the beginning of your procedure, later onwards you can change it as well. Okay, so that is the idea of a variable. It is a placeholder whose actual value can vary over a period of time. Okay, what other questions? Yeah, Shepherds, please answer the questions on chat. I'll just mute myself. There are some questions on the chat, Shepherds. Okay, so let me read out some of the questions.
Sir, my network went off. I just rejoined. So
It's
can
okay,
you
Aman.
repeat the questions?
No, it's okay. I'm just reading the chats.
Sir,
Yeah, go ahead.
sir, if discriminant calculator is not predefined, then we can be add its code in with bin.
No. Yeah, so yeah, you can also add the code in between if it is not predefined.
Okay. Thank you.
In fact, in the first in the slides, you will find one slide where it is explicitly calculated also. Okay, I mean, in the if you go back in the presentation in the beginning, there I have not used a discriminant calculator. There I am actually calculating it like B square minus 4AC.
Thank you.
So Akansha, it is the idea is like this. How do you assign the value? This is something that you have to understand, that if you know that the values of A, B, and C are going to be the same irrespective of what quadratic equation you get. Okay, then sure, you can write a statement in a pseudocode saying A equal to 2. So let me give you an example. Another way to calculate your discriminant, is by doing something like this. You say term 1 equal to b into b, and term 2 equal to 4 into a into c, and now d equals term 1 minus term 2. Okay, this is another way to write the same thing, right? Now here term 1 and term 2 are another variables, two variables, okay, and their value in turn is dependent on the values of b, a and c. Okay, so now this is what happens. Data flows in your program. Your user is going to provide you certain inputs. Then there will be multiple variables throughout your program whose values are going to be either directly the value that user provided or a function of these values. Okay, so this is the overall idea that uh, the shown um, again the quadratic problem solver. So Aman, you are saying about this the box or this picture. What is it that you want to understand?
Sir, box.
Box. Okay. Okay. So guys, please explain this box. Some shepherd can explain the
So
box.
the box here is indicated by the arrow. That is, we calculator, we take input and take the control discriminant equal to 0, then the root
It's lagging.
of minus. Oh, sorry. Wait a minute. Now, hello.
Yeah, it's fine.
Okay, so I was saying that if the discriminant is equal to 0, then the roots are equal, then we use this uh, equation to take out the values, the formula minus b divided by 2 into a. Else, if the discriminant is greater than 0, then we use this formula and the roots are real but unequal. So we use this formula minus b plus root 2 into a and minus b minus root d upon 2 into a. And else, if the discriminant is less than 0, then it is imaginary root and output that the roots are not real.
So is the box clear now?
Yeah, sir, it is fine. And once explain the procedure quadratic equation, that's the equation below.
So this you want this picture to be explained, is it?
Yes, sir.
Yeah, go ahead. Any of the shepherds.
So this box is the quadratic equation solver, the application, the first application which is being used. In the first application, we take the inputs A, B, and C. Then the quadratic equation solver first application asks the another application is the discriminant calculator. It calculates the value of A, B, and C using the B square minus 4 is C formula, and the output of that equation is taken from the second application to the first application, which is the quadratic equation solver. And now we have the value of d. Now all the if else statements are checked for the values of d, and we get the roots for the equation for which we have given the values a, b, and c.
Okay, thank you.
Okay, I hope it is clear. We have a few more things to discuss, but still, we can spend a little more time. As I said, for those people who are starting new with programming, this is very important. You have to understand this transition from mathematics to programming. So if you have any doubts, we are ready, right? We are still going at actually a very very slow pace. But once I jump into programming, which will happen today, then I'm going to run very fast. So this is your time. Okay, if you have any doubts about what a program is, I mean what an algorithm is, what a procedure is, how did we write a procedure for solving quadratic equation, how did uh, ABC become variables, x1 x2 become variables. If you have any doubts, please ask today, because otherwise you will fall behind. This is especially for the people who are doing programming for the first time. Okay, I'm trying my best to make these things understandable to you, but you'll have to put in your own efforts. So I guess it is clear. If you have any questions, ask. Yeah, go ahead.
So I want to ask that, for example, in our code we mentioned that a equals to 5, b equals to 6. Means we are not writing our code for a general quadratic equation. We are writing it for a specific
Ah,
quadratic equation.
yeah,
Then
Like for any
there will be
quadratic equation.
variables or constants here. A equals to 5.
yeah. So basically, this is something that you have to understand. There are constants. Okay, there are constants in programming languages as well, and the idea of writing something like of the idea of making a particular value as a constant is that you basically tell the compiler that the guy who is going to translate the code for you that see, from here onwards I am not going to make a change to this value. So if I try to accidentally change the value, please stop me from doing that. Okay, so what you just asked, if you are solving a particular uh, quadratic equation, you are not solving a general quadratic equation, then there is a way to declare your variable as a constant. Okay, so it becomes a constant that its value cannot be changed later. There is a way to do that. When you start coding, you'll understand this. But Subrat, do you have a question? Okay. Um, so yeah, so there is a way to declare constants explicitly as well, or otherwise the implicit way to declare constants is that instead of declaring A, B, and C, I'll basically go there in the in on the statement. Let me just say the statement where I have written d equal to discriminant calculator. There I will simply go and write 5 into 5 minus 4 into 1 into 3. Okay, so this is another way. So this is basically the implicit way of providing constants. So there then I basically uh, skip writing a b c altogether. I simply go and calculate the discriminant if I am doing it for a specific quadratic equation. Okay, so there are two ways to do this. I can either create a variable, and so there is a way to basically say this variable is not really a variable but a constant. There is a way to do that, or I can simply use the constant wherever I want. uh, Yes, Rishi, that is the point. That you need three input values. You can eat. So what Ria is trying to say is, what if I want to solve a particular quadratic equation only? I'm not trying to write a program to solve any quadratic equation. So then, does A, B, C become constants? Yes, they do become constants, Ria. And this is the idea that they will become constants if you are trying to solve a particular quadratic equation. Okay. Aman, the a formula is there. It's just that it is not written there. There is a procedure called discriminant calculator, and that procedure is defined separately. You have to go back and check your slides. Okay, uh, this is there in the slides. You will have to go and read.
Sir,
Yeah, go ahead.
sir, if we are using that, if we are writing that D is equal to discriminant ABC, sir, i- we are introducing the concept of functions here.
The concept of
So functions.
yeah, this is the concept of functions. Okay, but as of now, because I have not told you what functions are, just assume they are mathematical functions, right? So what mathematical functions do you already know? uh, so you know the equation of hyperbola and parabola, right? So what are their equations? Can anyone like tell me? So if I give you a value of x, You can give me a
Y
value
square
of
is equal to 4ax.
right. So if I give you a value of
Parabola.
x, yeah, if I give you a value of x, you can tell me the value of y, right? Of course, I'll have to tell you what is the value of a, right? If I tell you the value of a, you can tell me the value of y. And so
Yes.
basically what happens is, for one parabola, the value of a will be the same. What will change is the value of x
X
and
and
the
Y.
value of y, right?
Y.
So this is exactly what. So what is happening in discriminant calculator is that there is a fixed formula, right? So
ABC.
the formula is b square minus 4ac instead of 4ax. Okay, and a is also fixed. uh, in parabola, a is fixed. Here basically you will have to tell what a's value is, right? Now this is the idea, that when you're writing a program, whatever things can change. So as Ria said, if you are solving it for a particular parabola, then a is fixed. If you want to do it for all parabolas, then even a will become a variable. Is it getting clearer, or even more confusing? Okay, I'm just trying to make it more easier to understand. So the idea is that you are trying to use,
Sir,
this
for
this
single operation, it has to be fixed, no?
sorry, for
Single operation, it has to be fixed.
Shaban, your voice is breaking. You can type it on the chat. Okay, so yeah, so is it clear, guys? Like why what exactly is discriminant doing there? Why are a, b, and c variables? When will a, b, and c not be variables, as Ria has already pointed out? So if you just want to solve one particular quadratic equation, then a, b, c and are not variables. If you want to solve for all quadratic equations, then a, b, and c are variables. Okay. So uh, for single operation, uh, single operation basically, for one particular quadratic equation, you need values of a, b, and c. And if you are going to solve the same quadratic equation every time, these a, b, and c can become constants. But if you are planning to solve different quadratic equations, then you will have to ask the user what are the values for a, b, and c. This is the idea. So we have like little more to talk about. Is it clear, by the way, before we move ahead? Any more questions? I'm willing to spend more time on this. And you guys can also, of course, keep on sending me emails if this is not clear to you. This is, again, I repeat, this is specifically for those guys who are doing a first course in programming. This part, if you understand this part, it is going to be a huge step in your learning. Okay. um, so I'm assuming, guys, it's clear. Okay. And as I said, you can of course get back to me over email. So let's just talk about one more thing today, and that is library functions. So Shepherds, just take it up from here. Shepherds, library functions.
So library functions is something like a inbuilt inherent code, which is actually in most of the programming languages. Like it is already, it is basically a code which is actually given in the language. It's like a, you can say, a pseudocode type something. Uh, like for if you have to calculate square root in C language, then you use the mass function to give the input, and then the output will be given. Like, you want to take over?
Basically, library functions are those which have inbuilt code written in them, and we can reuse the code, the proper codes, for our general purposes, instead of writing the whole code again and again. For example, we use input output library functions, and for getting the square root of a number, or other math functions that are not basically we have to code for them otherwise.
Let me just resolve something going on the chat. So, Prerak, I think the problem is something like this. So basically, um, in the current pseudocode, we don't change the values of variables once we have assigned them, and this is logical, right? I mean, you only get the values of A, B, and C from the user, and then the program is very simple. But in general, that is what I think Dhruv is pointing to, that in general, variables values can change. Okay, so it is possible. For example, if you are a person who's just trying to be naughty, you can basically say the user gave you A, B, and C as 5, 10, and 15, but you say, okay, what I'll do is I'll do A equal to A minus 5. So whatever value user gave, I will subtract 5 from it, and then I will solve the equation. Or I will change B by making it B by 2 or B into 2. Okay, so this is all possible. The computer is not going to object to it. Okay, it won't actually ask you why are you changing the values that user gave you. So in theory, it is possible to change the value of variables at any point of time. It is you. I mean, you decide when a variable's value should change and when it should not change. So in this case, the value of variables should not change. Whatever values user provided, you have to stick with it, uh, it's okay, guys. Don't don't take this at personal level, right? Sometimes it happens.
So this is exactly what I mentioned earlier, that it can be changed unless and until we ask the program to change it. But for this
Okay.
particular program, we have not asked it to change the values of A, B, and
Yeah,
C.
yeah.
So they
Right.
will remain constant till the end until we
Yes, yes,
change
yes.
them.
Yeah, yeah. In
It
in this in
basically
this yeah in this procedure, it will remain the same. Okay.
Yes, sir.
it entirely depends on the user.
It depends on the
It
programmer actually, that you can write some code where you can modify the values. The program, the computer has no issues. You can change the value of a variable any number of times. It's just that when you will start writing code, you will realize that you don't randomly change values of variables. For every change there has to be some logic behind it. So it's that the idea is that variables in general are something whose values can vary. It's just that when and how they vary, that depends on your logic. Okay. Yeah, so sorry to interrupt like this. Yeah, someone was explaining library functions. Please go ahead.
Library functions are the predefined tags given by the code actually. For example, the end L code is used to change the line, or the cout is used to print the values. These type of codes are called the library functions, which are already defined by the code which we are using. For example, in C++, end L and cout are used. These functions are the predefined library functions.
So I have not yet talked about cout or printf or stuff like that. For now, just assume that you have to calculate a square root, right? The square root of d, that has to be calculated, right? The computer doesn't have a by default way of understanding what square root is. So you will actually have to tell how square root is calculated. Now you understand that calculating square root, that what was it called? Long division method? What, that way of calculating square roots, I forgot the name for it. I've been away from mathematics for very long time. But it was a very messy way, right, where we used to calculate square root, how to do square roots. So calculating square root is a very messy thing. So usually what happens is programming languages will actually provide you a way to access some common functions that a lot of people would need. Functions as in I'm not talking about any programming language functions. As of now, I'm just talking about mathematical functions. So all I say is y equal to sqrt of x. Okay, sqrt, and then small brackets and x. What it really means is that if I give this function the value of x, y will be the square root of x. So just assume it like this. So uh, yeah, thank you, long division. I just keep on revising my own concepts when I sit with you guys, right? I mean, I also take advantage of revising my own stuff. Yeah, so basically, the long division method is a very messy thing. Just imagine if you have to write an algorithm of how long division method works. By the way, you can do that. If these are all practice questions for you. If you feel that I would like to write the algorithm of how long division method works, go ahead and write it on a piece of paper. But by default, C does provide you this feature. Okay, so there is someone else has written the code for long division method. Someone else has written a procedure that calculates long division method, that calculates square root. All you need to do is just pass it a value, and it will return you the square root of that value. So library functions are basically pre-written procedures that come shipped with your language. Okay, you can simply use it and get your work done. Okay, so this is the whole concept of library functions. Anyone has any doubts in this, please ask. So we already have like reached the time as well, and I think we've been able to cover the stuff that was meant to be. I'm really sorry for not being able to give you the lectures for tomorrow. So what I'm going to do is, I understand you guys are very busy. Some of you replied to my email and you said that you guys are busy from 9 a.m. in the morning till 9 p.m. in the night. So it becomes difficult for you guys to watch lectures at short uh, short deadlines. So what I will do is, I am going to create two lectures today, and I will try to keep them to 10 minutes each. Okay, so there will be like two lectures of 10 minutes each. So essentially 10 minutes, I'm just requesting you to get up early by 15 minutes and watch those lectures in the morning itself. We will do at least some discussion. Don't worry, if we are not able to discuss it completely, I will take an extra class. Okay, to discuss. Somebody has something to say?
Difference between procedures and library functions.
Library functions are pre-written procedures that are provided to you by by the language itself. Is it clear?
Okay.
Yeah, so basically this is a procedure that was written by someone else. It is not written by you, but you trust that person, and you trust that person, and you simply use the code that that person wrote. uh, uh, Shaban, you'll have to talk to me over email. Send an email. We'll talk. Um, uh, so, uh, uh, you know, uh, any more queries about this, guys? I will, as I said, I'll create. Two. Yeah. Go ahead, Vanshdeep.
Sir, what are the timings for lab, sir? It is from 4 to 5 or
Do you guys have a lab today or tomorrow?
sir tomorrow. I'm
So,
from
Tomorrow.
sorry, your connection is breaking.
the
You will
CS2,
have
sir.
lab.
Sir, sir,
Yeah, so
tomorrow.
you will have your lab tomorrow, right? So you'll have your lab tomorrow at so what is it, 3 to 5? Something like that. Yeah, so tomorrow 3 to 5 you have your lab, and there will be a lab exam, and this exam is basically of bash. The CSAI batch, I think they have it today. So you guys have it tomorrow.
Sir, we have another lecture at 2 to 3 tomorrow. So
like half an hour. You said that you'll give half an hour extra time, right? So
Yeah. Oh, okay. So I will send you the problem statement at 2:30. And this lab is only a 1 hour lab, the first lab. So it is,
no,
you
actually,
don't,
is it fine to keep 4 to 5 because we have another lecture at 2 to 3?
sorry, your voice, it is fine to keep 4 to 5 because
So we are having another lecture from 2 to 3 tomorrow.
you're having another lecture from 2 to 3 tomorrow.
Yes, sir.
Okay. I guess it should be fine. I would like to start it, let us say then at 3:30. Shall we start it at 3:30?
Yes, sir.
Right?
It
So,
will.
Yes.
so what I'll do is something like this. I will send you the problem statement at 3. Okay. The lab will start at 3:30, and you will have to make your submissions by 4:30.
Ma,
Okay.
no coffee no.
Yeah. Someone.
बनाया बाबा, रुको जरा, क्लास चल रहा है. अब प्लेट उठो मत आप.
My mute कर लो.
Ayush, your mic is was on. Um, Yeah, I understand this, right? I mean, don't worry. It happens with me all the time. My son keeps on walking in where I'm currently sitting, and he asks me, "What are you doing?" And so it's fine, right? uh, okay. So yeah, so we'll start at. I'll send you the problem statement at 3. You will get like half an hour of. It's okay, Ayush, no problem. So we will get half an hour of. You will get half an hour of preparation time. Okay, so read whatever you want to, probably read a few man pages, and then the lab will formally start at 3:30. You will have to make your submissions by 4:30, and then your TAs will start taking the demos. Okay, so this is how we will do it. Okay, so because you have a class from 2 to 3, I'll send you the problem statement at 3. Is it fine, guys?
Yes, sir.
Okay.
Yes.
Okay.
Sir, from 4:30 we have to take the demo from the TAs.
Yeah, so your TAs will, as I said, right? Let us say you have, it that this is between you and your TA. You will have to arrange, you will have to find an arrangement. So your TAs may not have time right after 5 p.m. You may not have time right after 5 p.m. It is just that, it is between you and your TA. You guys will have to figure it out. When should
Uh,
your demo.
Sir, how do we know that which TA we have to send the email? We have not.
That, no, that you will get emails from the TA that is assigned to you. Okay, you will only
Okay,
receive
sir.
one email. The TA who gets assigned to you, that person will send you an email. Yeah, there will be a group of 20. You don't have to worry about it. Your TA is going to send you an email. Okay. Uh, that will be at about a 1 and a half hour before the lab starts. You will get an email from your TA. And you don't have to worry which TA it is going to be. Some TA would be there for you. Okay. And exactly how the demo works, that is between you and your TA. You guys can sit together and decide. So if you are not free, if your TA is not free, you somehow have to schedule this. Okay, you have to learn people skills. Talk, be be kind to your TAs, and they'll probably be helpful. So I think everything is clear, guys. I'll give you 2 lectures by night today, and just at least try to watch one of them. They'll be not more than 10 minutes each. Okay, so at least try to watch one of them. I'm not forcing you. I don't have the moral right to force you, because I am late this time. And is someone saying something?
Sir, yeah, I am audible.
Yeah, you are audible.
Yes, sir. So we have to submit any assignment in tomorrow in lab.
Yes, it is all labs are always going to be exams. Okay, all labs are going to be exams. Okay.
Every lab count marks.
Yes,
Okay.
just read an email that I have just sent. Okay, lab absent days. So almost every lab. Okay. Yeah, we will have class, Akshay. As I said, if no one has studied, I will try to figure out what to do. But you know, let us meet and at the time of the lecture. I mean, we have so many things to discuss anyhow. Even if we don't have new stuff, we can still discuss some of the old stuff. Yeah, go ahead. Go ahead, Sarthak. Sarthak, do you want to say anything?
No, sir. No, sir.
Okay. Yeah, Rishi, the TAs have made the batches. They will send you an email. Okay, don't worry. You will get an email from the TA that is assigned at 12:15. So let's just break. And sorry for this time for the lecture. I will give you the lectures by tonight. If you guys have not studied, we'll do something. We'll see what we can do. Um, but we will meet in our regular lecture time tomorrow. Okay, we'll see what we can do. Okay, so thank you guys. Uh, we'll meet tomorrow then. Guy, bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.